Hello everyone, welcome back to Particulate Technology course. So today we are having the final session of the second unit, size separation. So we already have discussed a number of size separation operations in the previous discussions. So let us now see what we are supposed to discuss in today's class. So in the last class, we took up the two operations, that is jigging and froth rotation. So we understood the construction and operation of hydraulic jig, then also the flotation cell. The contents for today's session are electrostatic separation. So we are here discussing the principles and applications of this operation. Then also we have to learn how to operate or how an electrostatic separator works. Later on, we'll be discussing about the magnetic separation, its basic principles and applications. And later on, we'll be talking about the construction and working of various kinds of magnetic separators. And later on, we have to discuss about the other separation operation, that is tabling. The one type of tabling equipment, that is refilled table, is taken and its construction and working is studied in today's class. So the first operation we are considering is a electrostatic separation. So electrostatic separation is that method of separation of solid particles based upon the difference in the attraction or repulsion of charged particles under the influence of a electric field. So we need to create an electrical field, and in that field the different particles based upon their different surface charges will behave differently. So either they are attracted towards the electrical field or they are repelled from the electrical field. So this difference of electrical characteristics of the particles are utilized to separate different particles of different materials from the given mixture of solid particles. So in this way, electrostatic separation is that method where different materials are separated based upon their different electrical characteristics. So the basic principle that is used in an electrostatic separator is when you have a mixture of one or more materials in the granular form, the different particles can acquire a surface charge in different manner when they are passed in an electrostatic field. The grains or the particles of the material will then be attracted towards an active electrode based upon its surface charge, and the one which have the opposite charge will be repelled by the electrode. So in that way, we can make the particles to move towards an electrode or move away from the electrode. So that helps in collecting the different particles in the given mixture into two different fractions. So that is the principle involved in a electrostatic separator. So this is a simple sketch showing you the operation that is involved in a electrostatic separator. It consists of a ground rotor or a rotating drum, so on which there is a hopper that is meant for feeding the solids which have to be separated. At a certain distance from the ground rotor, there is an active electrode carrying some charge. It may be a cathode or a anode. So the one here shown in the figure is a anode. Then when the particles are introduced on the grounded rotor, they acquire surface charges. So some particles acquire positive charge and some particles will acquire negative charge, or they remain as a neutral particles. So then the charged particles being positively charged on its surface will be attracted towards the electrodes. So as the ground rotor rotates, the particles that are falling down will collect in different bins at certain distances, because the charged particles having attraction towards the active electrode will be pulled toward, for a certain distance, and they'll be collected away from the grounded rotor, and the one which are not getting attracted by the active electrode will drop down below the grounded rotor as the rotor turns down, so they can be collected in a separate bin. So if we can provide a splitter in between the two bins will collect the different materials, that is, the different particles of different kinds of materials. So this is how we can obtain a separation in an electrostatic separator by creating an electrostatic field. So the particles will become conductive and non-conductive in nature. So when are passed onto the grounded rotor, the conductive particles will assume the potential of the rotating drum, means they'll assume they'll acquire the surface charge. So that surface charge acquired by the conductive particles will be opposite to that of the active electrode. So because of which it will be attracted towards the electrostatic field in the given operation. So while the non-conductive particles will not acquire any charge, so they'll not be attracted towards the active electrode. So and they'll be falling down right below the grounded rotor. So this is how we can separate out the particles using electrostatic separator. So that completes the electrostatic separation technique. Let us now understand the magnetic separation. So magnetic separation is that method of separating the solid particles into different fractions based upon the magnetic characteristics of the different materials. So the difference in magnetic properties of different materials forms the basis for separation in a magnetic separation technique. So this characteristic is responsible for the separation carried out in the process. The principle involved in the magnetic separation is that when a mixture of particles is taken, so some particles may be magnetic in nature, so they are the one which are attracted by a magnetic field, and such particles are called as diamagnetic solids, and the solid particles which are paramagnetic solids, and the particles which are not attracted by the magnetic separation or the magnetic field are called as diamagnetic solids. So if you can classify the given mixture as a mixture containing two kinds of particles, where one is a paramagnetic and one is a diamagnetic in nature, then you can separate out the mixture according to this classification by passing the mixture through a magnetic field. So when magnetic field attracts the paramagnetic particles, those particles will be collected as a separate fraction, and the one which are diamagnetic particles will be repelled by the magnetic field, so they will be collected at a place away from the magnetic field. So that is how we can collect the two different types of particles in the given mixture in two different separate bins. So coming to the applications of magnetic separators. So magnetic separators are basically employed in the mineral dressing operations again. So sometimes they are also used for separating out the tramp ion that might enter the material during the operation accidentally. So the tramp ion removal is one application of magnetic separation. So in that case, the magnetic separators are called as eliminators, or wherever the magnetic separation is used for concentrating magnetic materials from the non-magnetic materials, then they are called as concentrators. So there are two types of magnetic separators. One is the magnetic pulleys, another one is magnetic drums. So let us first take up the magnetic pulley, which is also called as magnetic head pulley. The equipment mainly consists of a belt conveyor, where one of the pulley on which the belt conveyor or the endless belt is mounted is magnetic in nature. So incorporates a magnetic pulley as a head pulley, the one which drives the other pulley. So then during operation, the feed is introduced at a point near the non-magnetic pulley, and as the belt moves due to the rotation of the pulley, the feed gradually advances towards the magnetic pulley. So then when the feed passes over the magnetic pulley, so due to the presence of magnetic field by means of the magnetic pulley, some particles will be tightly attached to the belt due to the magnetic force, and the particles which are non-magnetic in nature so will not be that much attached to the belt. So when the pulley turns, the material start falling down, and the materials which are non-magnetic in nature will fall off easily as soon as the belt turns on the pulley. So they'll be collected at a certain distance from the head pulley, while the materials which are magnetic in nature are not that easily detached from the belt because they are attracted by the magnetic field present there. So they'll be carried till the bottom of the rotor or the pulley. So when the particles actually loses the contact with the electrical field, they'll fall down at the bottom of the pulley. So they are collected at a quite different distance compared to the non-magnetic material. So if you can place a separating splitter at a convenient point near the magnetic pulley so that you can separate out the materials which are magnetic and non-magnetic in nature at two different locations. So the right side diagram shows you how a magnetic pulley can be used for tramp iron removal. So some material is flowing on the belt conveyor. It contains some iron particles such as stray pins, nails, or hammers, springs like that. Okay, these are the magnetic materials that have to be separated from the non-magnetic product. So here, as the material gradually advances over the belt, you can see that the stray iron particles are attached to the pulley when the pulley turns in the clockwise direction, and the non-magnetic particles are easily falling down as soon as the belt turns down. But the magnetic particles, that is, the stray iron objects, are attached to the pulley and are separated out at a certain distance from the non-magnetic particles. So you can see that in the diagram, the tramp ions are separated right below the pulley, and the non-magnetic particles are separated at a place away from the splitter. So that is how we can use a magnetic pulley for tramp ion removal. So other type of magnetic separator is a magnetic drum separator. The magnetic drum separator shown in figure consists of a rotating drum that incorporates a stationary magnet assembly in the inside space of the drum. So the stationary magnetic assembly that is used inside the drum creates a magnetic field for a certain portion of the drum, and that magnetic field is called magnetic arc. The magnetic arc approximately covers about 165 degrees towards the discharge side of the magnetic drum. The feed is admitted at the top of the drum and is allowed to fall on the rotating drum. As the drum rotates, the feed will be carried in the forward direction, and as the drum comes down, the magnetic particles will be attached to the drum due to the presence of magnetic arc, and the non-magnetic, that is diamagnetic particles, will be easily getting detached from the drum and they fall out at certain distance from the drum. The magnetic particles will be carried in contact with the drum till they lose the contact with the magnetic arc and they fall down under the drum at a different location. So this kind of operation is shown in the diagram. So where you can separate out the materials by the use of magnetic field. Another figure is shown here, how the iron particles are separated from the non-iron particles using a magnetic arc. So the magnetic arc is nothing but the magnetic field that is created by incorporating a stationary magnet inside the drum on which the separation takes place. So this shows the pictures of some of the magnetic drums that are used for separating the magnetic and non-magnetic particles from the given field. So next is a tabling operation. So this is another operation that separates the particles of a given solid mixture based upon specific property. Tabling refers to the concentration process where the separation between the two or more minerals of different densities is effected or achieved by flowing a pulp across a riffled plane surface, inclined slightly to the horizontal. So differentially shaken along the axis of the table. So that shaking causes the washing of the particles at right angles to the direction of shaking motion. So basically, a tabling contains a table of riffled surface so that the minerals which are having higher density are collected on the table, while the minerals having lesser density will be carried across the table by the fluid force. So that way we can separate out the particles according to their difference in densities in a tabling operation. In tabling, a separation between two or more minerals depend mainly on the difference in specific gravity between the minerals and to a limited extent on the shape and size of the particles. So basically, the specific gravity is the one which separates the particles in a tabling operation. So also to some extent, the size and shape also plays an important role in the separation of the particles. This operation is employed for concentration of ore and coal where there is a considerable difference between the effective specific gravity of the different particles. Effective specific gravity is the difference between the specific gravity of the mineral and the specific gravity of the water. So this effective specific gravity, if it is different from the various constituents of the given solid mixture, then you can separate them out into different fractions by using tabling operation. So figure shows a riffled table. So you can see the surface of the table, and in the spaces between the riffles you can collect the particles which are having higher density. So while the lesser density particles can overflow with the flowing stream of water and they get separated on the other side along with the flowing stream of the liquid. The riffle table mainly consists of a table, the surface of which is covered with a heavy battleship linoleum and provided with wooden riffles approximately parallel to the top edge. So the wooden rectangular pieces are attached to the top surface of the riffle table that creates riffles on the table. So the riffles are about 1.5 to 3 millimeters thick and 8 to 10 millimeter in width. So such wooden pieces are attached to the top surface to create riffles on the surface of the table. And the height of these riffles will be around 6 millimeter. The riffles may taper from one end to the other end of the table and are placed at about 25 millimeter distance from each other. The table is inclined at an angle of 2 to 5 degrees to the horizontal. So that is to make the advancement of the slurry from one side to the other. So it is slightly inclined to the horizontal. So coming to the construction of a riffle table, a reciprocating motion is given to the table at a speed of around 270 strokes per minute while dealing with the coarse material, And while handling fines, the higher speed has to be given. Around 350 strokes per minute are used when you are separating out the fine particles. The suitable launders means the collecting channels are provided at the end of the lower side of the table to collect the various products as they are discharged. The tables are provided with tilting device so that the transfer slope may be altered. That is, the inclination of the table can be altered by providing the adjustable tilting device attached to the table. So that is how we can separate out the minerals based upon different specific gravities using a tabling operation. So the picture here shows the real picture of a riffled table. So you can see that the wooden riffles are provided on the surface of the table. So that help in collecting the minerals having higher sizes or higher density, while the one which are lighter will be carried along with the slurry to the lower end of the table where they can be collected in the launder. So pick out the wrong statement in this four options. Magnetic separation method can be employed to treat both wet and dry ores. Magnetic separation method can be employed to treat only wet ores, or whether it is employed only for treating dry ores, or is it none of these. So magnetic separation can be employed for treating both wet and dry ores. So option A is the right option for this question. In electrostatic separation, the difference in dash of the different materials is responsible for separation. So we know that electrostatic separation utilizes the electrical properties of the materials for effecting a separation. So the electrical properties are the one which are utilized in a electrostatic separation to separate the particles into different sizes. So option B is the right option for this question. In magnetic separation, the difference in dash of the different materials is responsible for separation. So magnetic properties are utilized in a magnetic separation to effect the separation of the particles into different fractions. So option A is the right option for this question. When used for tramp ion removal, the magnetic separations are called as eliminators. When they are used for concentrating magnetic particles from non-magnetic particles, they are called as concentrators. So for this particular question, the option A is the right option. A riffle table operates at a speed of dash while dealing with coarse material. So different speed is to be used for different kind of particles. When we are separating out the coarse particles, the table operates at a speed of 270 strokes per minute. That is, the reciprocating motion gives the strokes to the material being separated. So that strokes is around 270 strokes per minute for coarse material separation. So in case of fine material separation, the speed is used is around 350 strokes per minute. So option A is the right answer for this question. A riffle table operates at a speed of dash for dealing the fine material. It is 350 strokes per minute. So option B is the right option. Dash is commonly employed for the concentration of ore and coal where there is considerable difference between the effective specific gravity of the material and the waste material. So this is again the principle of a cabling operation. The effective specific gravity of the material is nothing but the difference in the specific gravity of the material and that of the water. So tabling is the right answer and the riffle table is the correct option as answer for this question. So B is the answer for question number 6. So this is to recap what we studied in the today's class. We discussed about electrostatic separation, its principles and applications, and also discussed the working of an electrostatic separator. So we understood how magnetic separation is carried out, what is the principle involved, and where and all it has found applications. Then we also studied the construction and working of a magnetic separator. So then we studied also how the riffle tables can be constructed and operated to separate the particles of different specific gravities using the principle of tabling. So with that, let me end the second unit, the decisive separation. So thank you for being a part of the lecture in this particular section.